I'd like to say hello to everyone for joining us today for this podcast from the Light Review. Very, very happy to say hello to Matthew Nourse from RCL, from Remote Control Lighting. Hello, Matthew. How are you?
Very well, thank you. Lovely to be here.
Good to hear it. And all the way from over there, our good friend David Kriebel from LensVector. How are you,
John? I'm great, thanks.
That's really good. Now, I'm sure that basically anybody who's been to any exhibition anywhere at any time, David, will have probably tripped over you somewhere, and so you are a famous person in this community with your stuff.
John, I don't know that I'm famous, but yeah, it's been a lot of fun over the last many years to be involved with lots of new technologies coming into the lighting space, and I have to say, what's happening at LensVector right now is super exciting, and I think it's got to be one of the, if not the most innovative things happening in the last several years.
Absolutely. Now, before we start, here's a little story. This is because we're going to be talking about innovations. Really, that's what it's all about, isn't it? It's about finding something new to do. And I was the other week, I was commissioning a nice, lovely new restaurant in Weymouth for anybody who fancies getting down there and having some fantastic fish. And I was up a ladder, of course, on a double height space, of course, trying to focus a light and then fitting it with a lens so I could actually get the right shape of the light. And I was thinking, there must be an easier way of doing this. So that's what we're going to be talking about, because Matthew's got an easy way for us to do this, and so has David. We are, of course, talking about the ability to shift a light around, and then once you've pointed it in the right place, to adjust the beam. Two of those innovations that we're looking at. So I'm going to start off with Matthew, and we're going to just look back as to how this thing came about. Matthew, did it start out in that way? Was there somebody up a ladder going, for Christ's sake, there must be an easy way of doing this?
Yeah, absolutely. So there were actually two genesis points that happened almost simultaneously. My direct super boss, the owner of RCL, the guy who founded it, is Joe Ruston, and I always explain to him wherever I go in the world as a better looking Doc Brown from Back to the Future with better hair and a beautiful British accent. Right. And he is the professional wacky professor. He is the most knowledgeable person I probably know and the most trustworthy, but he also has a penchant for wonderful art and furniture. And so at one point he found himself in St. James's in London with a piece of furniture he was looking to get valued. And so he would take it into a few galleries. And in one of these galleries, he saw a man up an A-frame ladder. And I don't know if you've ever been in anyone else's property with their ladders. They're never solid and they're always rickety.
I've noticed that.
Yes.
Nor does anyone have a good ladder.
No.
Well, hopefully our system gets rid of ladders, but until then, you have to deal with rubbish ladders. And so there was this chap up a ladder about 20 odd years ago, and you could see the ladder was waving, woggling, and he's perching over the top of a very expensive table, trying to aim a spotlight onto a very expensive piece of art. And Joe, being Joe, asks the question to the owner of the gallery. He says, crikey, what would happen if that ladder gave way and he fell? And the owner of the gallery said, I know, he could really damage the table. Then simultaneously, the wonderful Sally Story of LDI and many other things approached Joe and asked Joe if he could work on a product that could help in re-aiming our spotlights on tables in a ballroom setting very regularly. Imagine you are wanting to re-aim pin spots every day, multiple times a day, for example, especially in the high peak periods of, say, Christmas or the holiday season. And Joe, being Joe, cobbled together very quickly exactly that, a remote controlled spotlight with motorized movement. And we still have that fitting to this day, and it looks as rough as you can imagine it does in your head. But from that moment on, he said, well, there's actually multiple markets for this. So that's really how RCL came about. There are many versions of it, and I'm sure if one day we were lucky enough to be blessed with Joe's presence on this, he'd give another opportunity. But those are ones that at least stuck in my mind.
Great, I love that. The creation myths. of technology. Yes, we could write a book, couldn't we? Now, with looking at the other side, from David's side, the first time I saw the LensVector product was we were at a, where was I? I was at a Lux one-day conference, and I was chairing that, as I used to do. And this guy comes up to me and says, "I've got something that you need to see." And I can't you see? I'm busy. I'm in the middle of a conference here. He said, "Can I see you later?" I said, "I'll see you at the end of the day." I'll get rid of this, whatever it is. But it turned out to be Tom Killick, and what he got is he got one of the first samples in the UK of the LensVector product. So it gets around about 6 o'clock in the evening, and I thought, oh, I've got to be polite because I've been quite short with this chap today. So I said, "You got something you want to show me?" He said, "Yeah, if that's all right." So he cleared a table and he turned it on, and he just went like that with an, and I went, "Everybody, come and look at this. This is the most amazing thing I've ever seen." And I took it home with me. And because it was the most amazing thing. So David, there's my little creation story about how me and LensVector got started. So take us back to the real creation story of how it turned into an architectural lighting piece of golden work.
Yeah, sure. So, I mean, it's really cool when you see something that makes you go, wow, like that. And you go, oh my, I didn't think this was possible. I mean, I knew you could do it, but I didn't know you could do it like that. And, you know, how we got there and how we got into the lighting space. We've been working with Tigran Galstian, who's one of the founders with Tom Killick of LensVector, has been working with liquid crystals for years, and working with them in imaging, for autofocus lenses, for cameras, for mobile phones. And as those markets were evolving, they also recognized, wow, I can use this to manipulate light, like for a light fitting, not just to focus light for a lens or eyeglasses or a camera or something of that nature. And that's when we got into the space of, oh wow, think about all of the applications in lighting. All of the times when we need a beam that's somewhere between a spot and a narrow spot, or between a spot and a flood. And think about how easy it would be with today's technology and the way we can integrate with wireless control, or wired control for that matter, something quite simply, and connect it. Because really, as LEDs evolved lighting, they really changed the way that we built light fixtures and that we design spaces. I mean, John, you probably no longer specify what lamp goes into a light fitting. You specify a color temperature, maybe, or you specify a variable CCT, right? Or a tunable color.
Exactly. Yeah.
Maybe you specify a beam, maybe you don't. Maybe you pick the beam pattern that's available. But the way we were able to digitalize lighting with LEDs really gave us that connected opportunity to do everything else with the light fitting as well. So what RCL's done in our ability to maneuver a projector, added with LED, now you add the ability to change that light source, the color temperature, or the color itself. The one thing that's missing is, could we possibly control where the light goes digitally? And as it turns out, liquid crystal and the liquid crystal technology that we've developed are exactly the way to create an array of what we call micro lenses that let you fully direct, customize, manipulate the beam of light. And that's where we are.
Now, hang on. This sounds even more exciting. Up to now, we've hey, we are still getting used to the idea that you take a narrow beam and you can turn it into a wide beam and any beam in between. But you just described something different, haven't you? You're saying now, unless I've misunderstood, that it's not just taking a circular beam and making it narrower or wider, but if you want it in the shape of a bunny rabbit, we can have it, David.
Yeah, well, a bunny rabbit, yeah, but
Or the day
yeah,
after
John,
tomorrow?
yeah, day after tomorrow. Essentially, the way the tech, I'm talking a lot about the potential of the technology, but the technology has the ability or the potential to be able to create many, many, many different types of light distributions. So as we work in architectural lighting at the moment, the products that RCL are using that are commercial are a very narrow to a very wide symmetric type of manipulation of the beam of light. And I'm sure very soon they will be doing something that's a little bit more progressive than that, might be more like an oval of light or something.
Wouldn't that be fun?
Yeah, along that type of scenario, right? But at the same time, we're pushing the technology and being able to use it in places like adaptive forward headlighting. So as automotives, as the automotive industry and automobiles evolve, especially in Europe, you have the opportunity and the regulation where you're going around a bend, there's a car coming the other way, your forward headlights are going to adapt based on what they see on the road so that the other driver doesn't get light in their eyes. And that means immediate modification and manipulation of the beam of light and constant. And it turns out like crystal lenses are really good for this. That's just one application. I mean, another one could be a handheld flashlight. Yeah. But in reality, John, this is the potential of the technology. We're here to talk about what we're doing with it today, right? And the coolest thing that is happening today really is the way RCL has added it to their portfolio, because it really, in my mind, I'm going to put maybe words in Matthew's mouth here, but it really completes that product offering. Because to be able to move a pin spot around is brilliant, but what if suddenly the table's bigger or smaller? Well, this really allows you to not only put the light in the right place from a directional perspective, but also make sure you've got the right size beam in the right place. And what I think RCL has done, other than be an early adopter and real leader with this technology, is they have made it so easy for the design professional to manipulate the beam because of their ability to design and write apps and user interfaces that, John, no offense, but even you, the guy who gets up on the ladder with his box of Sora lenses and clips them on,
I never mentioned them. Even
you with your iPad, your old Generation 2 iPad, could control this light.
Yeah.
Well, there's a challenge. Thank you. So
I think there's a good point there, and yeah, I suppose there are two essences that I want to take from that. The first is understanding how LensVector's technology has completed our offering, and I know perfectly well, having now worked for RCL in total of 12 years with a gap when I went back to university, but actually I went back to university to work on a final product, which was a variable beam width LED lamp for RCL. Because in my placement year of university, I went to work for RCL as a placement student, and being the company that it is, they trusted me and flew me globally, honestly globally. I was the most decorated of any of the students in my year for places I'd visited on placement year. I was so grateful for it, and still am. Because now I don't feel like I need to go on holiday. But back then, I was sent globally. I was playing with our spotlights, showing people our spotlights, troubleshooting installations. And I came away with the thought that it's great that you can aim our spotlights from the floor. It's brilliant. And it's great that you can do it by DMX even. And at one point, even DALI, but we don't like to talk about that because DALI never really adopted it. But wouldn't it be bad if a lamp failed? Because then I still have to go up a ladder. And so I thought, well, LED is clearly the future, even though at that time it wasn't. It was just wasn't there. That's what people say. It wasn't there, and that's true. The technology hadn't matured. And then I thought, well, okay, you've got to go up and down a ladder if a lamp fails, but you've also got to go up and down a ladder to add a wider distribution lens or a new AO111 halogen. Wouldn't it be great if we can combine those two technologies? I mean, once the light's up there, you don't need to go up and down the ladder or even shift it along a little bit, because suddenly you have control of that light source, which isn't going to fail. and you have control of its beam angle. And so I went away. Yeah, I would never even thought of LensVector even slightly working. And so I did it mechanically. And I came back, and although it worked, it was mechanical, and it would look great in a steampunk gallery, but not so good in a modern day contemporary art gallery. But I carried on this plan, and I was finding materials and technologies globally that might have made this work. And I found a piece of smart glass and gave that a try, and it just never worked out. And I found a piece of luminate variable diffusion sheet, which I thought was magic at the time, but you shine too intense a light through it, it goes completely clear and it's useless. And I thought, oh, maybe it's just not meant to be. And then I see LensVector, and it's just one of those moments, just like you had, and you thought, no way. And you're pinching yourself. And instantly you think, oh, this is just a variable smart glass. And then David goes, no, it's far cooler than that. And then you get into the depths of how it actually works, and you think, this is mind-blowing. Yeah. And then, of course, being our company is made up of nerds, really super smart tech nerds, and you give them a bit of technology, and they're instantly thinking of how they can interface it into our products. And so then the secondary part of that is, how do you give an end user who may not speak the same language as the RCL technicians, how do you give an end user an interface to control not only a motorized spotlight with pan, tilt, and dimming, and maybe color temperature, but how do you also give them the ability to change zoom? And so we had a handheld remote that we always had, and the modern one you can even play Space Invaders on, and you can change the beam angle, but the best was RCL Control, and that is an iPad interface that cost a fortune to develop, but with good reason, because it's the most streamlined, beautiful system for controlling at least our moving spots and LensVector, to a point where I can drag my finger on a disc and change the degrees of that beam angle, or pinch and change the degrees of that beam angle. And so suddenly within minutes, I can set up a space. But remember, we also have the ability to control scenes and record scenes. So you could go into your ballroom that one poor guy 20 years ago was up and down a ladder aiming, changing lamps that maybe have failed or were too wide or narrow from a previous event. And I can just press a single button, scene one, all of those lights go to their predetermined position, dimming, and beam angle. That's magic. And it's not even if tables get bigger or smaller. What if one table's closer to a light than another one is? Suddenly that one that's further away has a wider, dimmer light on it.
Yep.
With LensVector, I can widen the one that's closer and get them all looking the same, and then dim it back a little bit.
Yeah.
I love it. I love it. And it always makes people go, wow, even if they've seen it before. If you just show it to them on, I'm fortunate enough to light some really spectacular pieces of art. And I think now I can legally mention that recently we lit a 46 million pound Monet and a 30 odd million pound Rothko painting with LensVector enabled RCL lights. And it was great. You didn't even have to think. You turn up with the spotlights, you put them on, you aim them, and then set the beam angle perfectly. It's magic. It really is magic.
And Matthew, it really, when you talk about the scenes, to me, that really is also part of the next level, because we talk about how we change and reconfigure spaces in hospitality or in gallery settings or museums all the time, right? But to be able to do a lot of that ahead, I think there's immense value there, not only in the labor savings of the people on site changing things around, but you think about it when someone like John's involved as the lighting designer. They go to a project, they have an aim and focus. It's part of the project, it's built into the budget, whatever. They go, they do the initial aim and focus. But with an RCL system, the customer, the end user, can have the lighting designer go and do 5 aim and focuses or 7 all at once, all saved.
Yeah.
For
yeah,
all
amazing.
the different types of things that they're doing. So instead of John setting up the ballroom for the fantastic Christmas evening or Christmas lunch events, and that's it, because that's all the budget allowed, John or any other designer could go in and set it up for the high tea event, the amazing evening breakfast, cleanup, whatever it is.
Yeah.
And that's what I think is, that's where so much of the magic comes in one, the ability to control all those different parts and points of the light, but the software and the UI. And John, I mean, from your side, it gives you a little bit more, I think, to offer, possibly.
I think, well, hey, I was at that restaurant last week and somebody had moved one of the tables.
Oh. Out the rickety leg.
In my pocket, I got my phone. I could change the lighting scenes. I could actually, my phone can access their system, so I could. But if I'd got your system on my phone, I could have sat there and I could just have moved that beam, that foot while nobody noticed.
Yeah,
100%.
Because it's going to stay like that since forever. Because no one had noticed that table had shifted. And it's one of those things that just the thing that's intriguing here is that we think we're talking about two pieces of innovation. We think we're talking about the ability to do that with a spotlight and to do that with a light beam. But actually, it's this, a journey of 1,000 miles starts with one step.
Sure.
But the innovations that have gone on since then, the fact that you've got that software is innovatory. The fact that you've put those tunable lights in there as well, that's also innovatory. And it's almost as if you are now on the hamster wheel of innovation as far as this is concerned, because people like me are going to come to you and go, you know what we've been doing for the last few years with all of this stuff? What happens if we did this?
Yep.
And I've no idea what this actually means, but the thought process will continue. And I think it will be around the idea that even though we plan our lighting scenes, and part of the thing that your system allows is the ability to change a setting without getting up ladders, which is fantastic. We go from static scene to static scene to static scene to static scene. Yeah. And I'm waiting for the one where we go from dynamic scene. So the lighting actually changes while you are in the space. So even more theatricality gets introduced. So instead of just lighting a picture, we ended up with sort of, I don't know, interior planners, interior artists who can create things that we're looking at, but then will be lit dynamically. So we might end up with something, you think that you're looking at a landscape, and then all of a sudden, over half an hour, you realize there's actually what's happened is that the light beam has come narrower and narrower and narrower until you're focused on a tree or a lighthouse.
John, I think it's interesting that you bring that point up, because what I see happening in the world right now, as we move from static to static to static, all different types of environments are changing. So if we think about what's going on in retail right now everyone shops online. Go online, click, 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 okay? High street retail is changing. It's becoming much more experiential.
Yeah.
So these big high-end retailers are not going to have bricks and mortar stores everywhere. They've got that because you open up your computer and you can get to them straight away, right? But their high street shops are becoming what we call experiential retail. So you walk in and you have a retail experience with their brand or with a product. And that is becoming much more theatrical, much more of a themed environment where things are dynamic, where lights are moving, and the opportunity to create themed retail like that and experiential retail needs to be done, but needs to be done in a more cost-effective way than, say, a music set where you're using big multi-$1,000 moving headlights. And this is where an architectural lighting product like those that RCL have really fits into how spaces are evolving, because galleries change stuff all the time. Yeah, we need new paintings. Oh, we don't want up the ladders. That's sort of the initial step, right? We're going to move the tables around, initial step. But the way that RCL's integrated all these different technologies, and with their easy to integrate, easy to control, I fully expect this to move into what experiential retail. One, changing shop windows every 2 weeks, really simple. But even when you walk in, as you say, to the shop, and you see one thing and you walk out, and you go, I didn't see that before. And then those of us that are always looking up at the lights realize, oh, well, the light just moved from there to there. And yeah, I saw that on the way in and I wanted to buy that, and I see that on the way out. And now I've got 2 clicks that I'm going to buy when I get home instead of just one, you know?
We did a project actually in Ghent years ago at a Ferrari dealership. And the whole plan of this
You bought 2 Ferraris.
Yeah, you need to buy 2.
You need to buy 2 Ferraris. Okay.
But you wouldn't know it was there. It's quite offset back from a very busy road. And the way that the client wanted people to probably take their eyes off of the road and look over there was to actually create movement. So our lights there were specialized versions of our lights to enable constant movement. But that movement was triggering people to look round. And you can do that and more with LensVector now. And there's another, I was with a wonderful lighting designer. I'm sure the project is highly classified. I'm not allowed to talk too much about it, but let's say hypothetically there was a restaurant with a number of tables and the client specifically wants to be able to press a button when it might be a client's birthday at one of these tables, and all of the other lights go wide and dim and this one goes narrow and bright. And they come out and sing happy birthday to them. And then after that, they press their other scene and everything goes back to how it was.
Please, sir, can we have a moving spotlight that lights the birthday cake that comes from the kitchen to the table?
Wouldn't that be
a follow
awesome?
spot? I want a follow spot that follows the journey all the way to the table.
But no one will want to pay for it.
Oh,
but then maybe they would if LensVector could make the beam shift and tilt as well. The hardest thing about follow spots is actually tracking a beacon. And
yes. You mean like a forward adaptive headlight, maybe?
Maybe.
Sort of thing.
Solid state motorized lighting without the motors. Solid state moving lighting.
Solid state moving lighting.
Let me work on that.
Very cool. And super dynamic, no moving parts. You could just let it do this for ages. Silent disco lights. You kill the music and you don't hear.
Imagine that our ceiling looks like the screen that's behind David there. So and every one of those little holes is a light fitting. And everything's programmable. So you can follow someone who's walking through the space. Or you can have a wide beam or a narrow beam. We're going mad here.
Well, but it's fun because, we're talking about the future, and this is exactly how we got to where we are today. So I'm sure someone said, imagine if we had a light that we could go from cool light to warm light, and we haven't, right? So it's this type of dream, these types of fun conversations that make us go, oh, that's next. I bet we could take this from here and make it do that, just the same way Matthew and RCL got pushed. And that's the same way that we get pushed. And that's what's super exciting about how all of this works. I mean, as this all becomes very, I'll say, normal, I see a day when just good old-fashioned downlights that go into a residence all come automatically with a tunable LED and a tunable beam. Because there's a point where the cost and demand curves cross, and it's just easier to say, oh, well, if your ceiling's 8 feet high or 10 feet high or 12 feet high, it doesn't matter. You just put this in. And if you want warm white or cool white, it doesn't matter. It's the same thing because everything else can be fixed to the space, And I don't think we're very far from that being a reality, which think about it for outdoor in-ground lighting. I mean, there's so many fun things where it can all apply. I think the lighting world is following what RCL has done because they are right on the front edge of understanding what the design community, the architects, the lighting designers, the light planners want in space. And it's controllability, connectivity, and variability. And they've offered that. And they're really leading the way from an innovation perspective. And, you know,
adding to that, the other big buzzword, of course, and has been for years, is all about being eco-friendly and green. And if there's a way that by having multiple, to reducing the number of different lights in a space so that you no longer have your narrow beam spots for tables, your floods as well.
Yeah.
If you can get all those down into one set of lights, maybe they cost a little bit more, but there's a lot less cabling, installation, electricity probably as well.
Massive savings.
That's another part on the innovation journey. That's yet another step.
Yeah.
I'm going to wrap this one up because I suspect we can just keep going on. But the thing that is really heartening here, and it just makes the whole thing much more fun, David, is that everything we've been talking about is about the human experience. It's about being able to take a space and do something with it for the people in the space. The first LED I ever saw, somebody came to you and said, "What do you think of that?" And I said, "What is it?" And they said, "It's a light source." And I looked again. I said, "Can you turn it on?" "It is on." Right. What do you want me to do with it? They said, "Well, we're using it outdoor. We're using it outdoor at night." I can see how that might work. But we tend to sell tech.
Yeah.
Whereas here, what we're talking about is experience. It is the whole thing. Yeah. And I think that is absolutely terrific. And long may this journey continue. Now, for our guests who've been earwigging on this one, what we're going to do now this chat's finished is we're going to put on a little video of Matthew actually demonstrating what we've been talking about. Just in case there's anybody out there who's been in a cave for the last 2 or 3 years and may not, what the hell are they talking about? We're going to show you this. And so enjoy that. And in the meantime, I'd like to say thank you very much. Thanks to David for joining us from Vancouver. Lovely stuff. And from Matthew, who's not in Vancouver, because he's somewhere in the southeast of England. Not quite sure where you are.
South Greater London.
South Greater London. That's a place. I'm sure it is. I'm sure that's a place. Matthew, David, thank you very much for your time. We've managed to get from start to finish without too many cock-ups, I think, which is great. I'll see you all again soon. And ladies and gentlemen, thank you for your time and goodbye.
Bye, everybody. Thank you.
Bye. Thanks, John.
It's a pleasure.
Welcome to the workshop. Thank you so much for participating. The workshop is called Simplifying Commissioning with Advanced Lighting Technology. So that should give you a pretty good idea of what's going to be coming up. But in a nutshell, we're going to be showing you some amazing technology which speeds up the commissioning process dramatically, but also gives you some new tools to give you the exact ability you want to set up an installation just like you want it. You don't have to compromise. So, initially, big thank you to David Kriebel and LensVector for participating and partnering with us in this workshop. And we're going to hear from David Kriebel in the Q&A a bit later on. My name's Matthew Nourse. I've been with remote control lighting for 10 years. I've seen a lot of stuff, and I'm going to touch on a few of those things a bit later on. But first off, I want to give you a very brief introduction to who RCL is, and so why we exist. Well, let's go back 20 years. We're now 20 years old. 20 years ago, a lighting designer came to RCL's founder, Joe Ruston, and asked him for a solution to a problem project. An unusual project that we thought at that time, but what turned out to be a problem everywhere. She wanted pin spotting in a ballroom and came to Joe, as Joe is this whiz kid, and said, I need to be able to angle spotlights regularly every day, sometimes more than once a day in the busy seasons like Christmas. But I can't get a genie lift in. These lights are 10 meters up in the ceiling or 30 feet. How do I do it? So Joe came up with this idea, which uses a remote control. You press the red button, it emits a laser, shine the laser onto the sensor turns red, and now I can pan with left and right, tilt with the up and down buttons, and dim using these 3 buttons on the side. Around that time, DALI was also being used quite regularly. DALI was a dimming protocol, a digital dimming protocol, and it is very, very clever. It's easy to install, there are some good interfaces for it, but we're a moving lights company. So we were actually the first and probably the only company at that point to make moving lights which were controllable by DALI. The problem with DALI, though, is it's quite slow. I would move a light in DALI, I'd have to wait maybe a second or even a fraction of a second for the light to move. And that makes it very tricky when you're just sort of pressing buttons or moving a slider to angle a spotlight exactly where you want it without over judging where you need to go. So we changed and just were a DALI dimming company then. DMX, however, had been used for years in the theatre space and was originally designed as a theatrical control system to unify the protocol that theatrical lighting products used. But DMX is crazy fast. It's almost real time, maybe 23 milliseconds, a new signal is sent. And what that means is I can move my DMX slider on a theatrical control desk and the light moves almost instantaneously. So it's actually quite easy because it feels like I'm moving the light almost with a piece of string. It's really good. However, the interfaces for DMX aren't great. They tend to be theatrical sliders. Not very good if you want to pan a fitting by moving a slider up and down. It's not necessarily very intuitive. And we are, in many ways, not only a lighting manufacturer, but we're a controls company because we have a handheld remote to move our lights. The other problem with DMX we found is installations. Cabling of DMX, once done correctly, is super robust. But it's not always done correctly. And actually, more often than not, we've found issues where certain parts of the world, maybe more than others, the cabling isn't the right cabling. They haven't connected the lights in the correct daisy chain string with the terminator resistor on the end. And so, although we love DMX, we wanted to move away from it eventually. But at that point, DMX was the best port of call. So we created our own iPad app, which actually used DMX at its core. It's called iDirect. iDirect was a DMX-based control system which used an iPad to control the lights. How it worked very briefly is like this. I would tap on a fitting, I would then get a touchpad. I'd move my finger around the touchpad, the lights would move. I could use a dimmer on the side, and to select a light, I can even bring up a PDF floor plan of that space, zoom in to where I want to control, tap on a light, and do it all again. It was very, very good for the time, but it did have its limitations. One of the limitations was number of fixtures. It was only a single universe. It still always used DMX cabling, so unless you're guaranteed to have good DMX installations, it's not guaranteed to work perfectly well. In many cases, it absolutely did, but you are still reliant on having someone that knows what they're doing. The other one was interfacing with other control systems. If I was in a ballroom, and no matter how much I would love this to be the case, it's simply not the case that we're the only lights in that space. So you may have cove lighting, RGBW cove lighting, wall lights, maybe general illumination lights, and they're going to be controlled by another control system. We couldn't interface well with that control system. We could scale dim, but we couldn't recall scenes or anything advanced. So we wanted to go on to the next level. Enter a new app, RCL Control. RCL Control is an iPad app. It communicates by Wi-Fi to a network. And on that network, you have a mediator box, the RCL Control mediator box. But from that box to all of the lights, and from each of the lights to all the other lights, it is a thread mesh network. Thread is a protocol that works on 2.4 gigahertz, very similar to Wi-Fi, Bluetooth, Zigbee, Z-Wave. But Thread is incredibly advanced. It's super secure. It uses the Internet version 8 protocols level of security. All of the lights can automatically reconfigure themselves depending on the topology of that space you're in. Some lights can be repeaters and spread that information out to all the other lights. Some lights can just act as standard lights that receive a signal and do what they want. And it's also always bidirectional. But how does the interface work? Well, this interface that you're looking at now in the bottom corner, or now full screen, shows 2 zones and 7 areas. This is a hypothetical museum which we've just created for you, and my favorite gallery, because it's the only gallery with lights in, is the Ice Age gallery. So I'm going to tap in that gallery. This shows the full screen of that gallery, and I can actually zoom in to our lovely woolly mammoth. I can zoom into fixtures, and I can tap on the fixtures. And I'm going to tap on the fixture which is next to me right now, number 3. You'll see now that a control panel has appeared on the right-hand side. I want to turn the light on, so I'm going to tap on the dimmer slider and move my finger along. On the light comes. Pretty easy. If I want finer control of that dimming, I'm going to tap on the slider, bring my finger down, and now I get much finer granularity. This is probably a good time to admit that the camera setup we have, although I think is very good, doesn't do the lights justice, and so you'll have to take my word for it. It looks a lot better in real life than the webcams are showing it. But that's how we control the dimming level. If I want to move that spotlight, at the bottom right of that screen, I have the joystick commands. I can tap anywhere in that circle, doesn't have to be in the middle, and I'm going to drag my finger to the left, and you'll see the fitting move to the left, drag it to the right, it'll move to the right, same for up and for down, or any combination of those two. I can also move the light using the jog wheels. I find these pretty amazing. This is a jog wheel for pan, and you'll see that if I move that little indicator around, the light fitting moves. If I move it back, it'll move back. But you should also see that there's a trail, an orange, slightly darker trail of where that light is and where it's going to. What that hopefully is telling you is that that fitting is talking back through the thread mesh network to the mediator box, to the iPad, and updating its current position and what it's doing. Why is that important? Well, it always tells the system where it is, and it means that I can take another iPad or even that humble, relatively dumb remote control, select the light with a laser, pan it round, and you're going to see it move on the screen. That's amazing. It means I can set up a giant space like we're fortunate enough to have. You know, we've done some ballrooms which are 700 fittings large, and we can set them all up with multiple people doing it. Speeds things up dramatically. For this though, I'm going to bring it back into the middle, and I'm going to use the tilt just to make sure that we're in the middle of the screen. Maybe a little bit more pan. Nice. This fitting is also a little bit more special because it has color temperature control. I can move my finger on the slider just like the dimmer slider and go from 2200 Kelvin all the way up to 4000 Kelvin. If I want finer control, I tap on that slider, bring my finger down, and now I have much, much finer control. Really cool if I'm setting up some art and I just want to get it perfect. It's really handy when you're dealing with a gallery that actually shows multiple types of art. Maybe not old masters and black and white photographs, but different types of art does need different color temperature of lighting to really make it shine. And in a commercial space where it's very important that the art looks its best, because that's the only reason it's there, it lets you tune that from where the clients will be looking at the art. Brilliant. You'll notice there's another tab next to the dimming, and that is beam angle control. This is where I get to talk about some amazing technology from LensVector. This is a LensVector panel. LensVector is a manufacturer of electronically adjustable liquid crystal optics. Depending on how you control the electricity passing through this two-layer sandwich of glass with a liquid crystal membrane, you can control the orientation of these tiny liquid crystal lenses and bend the light traveling through it. It's awesome technology, but let's have a look at it working. Using that same fitting next to me then. If I want to change the beam angle, I tap on beam, and now I have another control type. It's not a slider wheel, it's actually a pinch to zoom disc. I put 2 fingers on it, and I pull it back in, and you'll see the beam getting narrower. If I want to make it wider, I enlarge it, and it gets wider. All the way from the narrowest, which this particular fitting goes to, is 15, all the way out to 60. The way a LensVector panel works is you start off with a narrow beam collimator, or really any beam, but we like narrow beams. So in this case it's a 15, but it could be one of our 6s, our 10s, it doesn't matter. And then it spreads that beam from there, in many cases up to beyond 50 degrees, which is amazing to have that level of control. And that's what I mean when I said at the beginning, technology that can get your installation ideas exactly right. You don't have to go from 6 to 10 when you actually need an 8. You don't have to go from 10 to 24 when you actually want a 15. You can do that with the LensVector. So it enables you to set up your installation exactly as you want it. I think it's amazing. So let's move on to the demo wall. You see just behind this lovely camera here. Currently we have 2 LensVector fittings shining at it. There's a picture, a photograph from the Science Museum. Both of these are set to be quite wide floods. I'm going to send them to their narrow beam position. And you're going to see that the LensVector works pretty well. Both of these lights are now on their full intensity and narrow. I can now go to their wide again, and you should see these lights move and get wide. But I'm also now just going to light the picture up briefly. Remember I said before it's very hard to get these lights looking like they do in real life. The way I'm doing this here is when they're narrow, I've actually got them dimmed down a little bit, and then when they go wide, I increase the intensity just so that you can see that they've gone wide. In reality, it works a lot better than that, but it is as far as Logitech webcams go. Scenes are really important to us because it enables us to recall positions very, very quickly. You'll notice on the right-hand panel when I click in the Scenes tab, I have 4 scenes. Nicely lit picture, narrow LV show, etc. Each of these scenes recall the pan, the tilt, the dimming, the color temperature, and the beam angle of either all of the spotlights or just some of the spotlights. And we'll get onto that, some of the spotlights, in a second. You'll also notice that next to nicely lit picture, it has DALI 3 written on it. DALI 3 is a DALI signal because our mediator box can now take in external signals from other control systems. You remember that iDirect's one of its limitations was its ability to interact with other systems. But RCL Control's mediator box can take in a DALI or DMX feed, and maybe in the future some other ones. So I can go over to a DALI wall panel, a standard DALI wall panel, press scene 3, and those lights will go to scene 3. Awesome. Let's talk about groups and multiple selection. If I click into the Selection tab in the middle of Scenes and Control, I can now tap on any number of fittings in order and select them all. You'll now see on the right-hand side control panel there are 4 lights selected. That's just with me tapping. But what if I've got a massive installation and I just want to select a single group? I can tap on Group 1 and it picks both of those lights together. I can now go back into Control and you can see 2 lights are there. I can now dim both of those lights together by using the bounce slider. When I let go of my finger, the slider stops and returns to 0. And the reason this is a bounce slider is because lights might be at different levels to start with, and you want to keep those levels difference the same as you dim them. I can select all the lights if I wish, and then all of the lights get selected, or I can deselect them all just as easily. But what about that large installation? Well, our system works in bidirectional manners. So I can't have a fake installation with lights that don't exist because the iPad will shout at me and tell me how wrong I am. So we have a video that we recorded in a real installation with lots of light fittings that we're going to play for you now, and I'm going to explain the screen capture and what's going on. This is the RCL Control main interface. We're going into one specific room here, and you'll see that there are 4 colors of lights. We have red lights, blue lights, yellow lights, and pink lights. All of the red lights are shining on tables, the blue lights are on columns, the yellow lights are on a staircase, and the pink lights are on a bar. If I want to select all of those red lights together, I go into Selection, and then I press Group 1, and all of the Group 1 lights are selected. I can add to that, so I can pick all of my blue lights and yellow lights and pink lights. Now, every light in that space that is RCL controllable has been selected. We now go into the control panel. 79 lights have been selected. I might want to dim them all together, so I can use that bounce slider, and all of those lights will dim together, maintaining where they are in dimming level compared to each other. We can rotate them and tilt them, like we're doing in the bottom right with the joystick command. When I let go of that joystick, it will return to its center point, and all of the lights will stop moving. So we can actually move all of these lights simultaneously. Color temperature control. It might be a lovely afternoon. 4,000 Kelvin sounds perfect, but wow, where has the time gone? Let's crank it down to 2,200 Kelvin and enjoy a lovely, warm evening romantic meal. We can also control the beam angle of all of these lights together using the pinch to zoom disc in the beam angle control system. So how about a quick recap? What have we seen today? Well, hopefully you'll agree that you've seen some amazing technology. First off, LensVector. Can't thank them enough for partnering with us. But for me, LensVector is an amazing piece of technology. Remember at the beginning I said I've been with remote control lighting for 10 years now. I've actually been with remote control lighting for 11 years, because in my middle year of university, I came to work with RCL as a student, was fortunate enough to be sent all around the world. I would be sent up long ladders, high genie lifts, to help commission and set up light fittings, but also to meet people. And one thing I learned back then is no matter how cool it is to be able to move a spotlight from 30 feet up in the air from the floor with a remote, if I need to change the beam angle because the picture on the wall is suddenly a bit bigger, I'm going to have to go up and down a ladder again. So it stuck with me. What RCL really needs is variable beam control. So in my final year back at uni, before I came back to work for RCL, I actually designed a variable beam width LED lamp. That shows you how, in my core, variable beam width is. And LensVector now releases this amazing bit of technology, fully electronic liquid crystal beam control optic. And it's so thin, you know, it's probably 5 mil thick. And what that means for us is, without mechanically extending the length of the snoot or adding motors, multiple optics, we can change the beam angle from a narrow, say 6 degree, all the way up to 53 degree. Equally, in the future, and we can poke David about this in a minute on the Q&A, he suggested that very soon we might be able to control more than just the beam angle. We might be able to make a linear lens, a portrait lens. Great for wall washing, great for aiming at art, which is something I love doing most of all. And then, of course, RCL Control, the third iteration of remote control lighting's ability to control our lights, and one day, maybe others too. It's been designed with the end user in mind, be that a lighting designer or, in fact, an end user in a ballroom. It uses wireless technology, great for existing projects that's already got track in the ceiling. Put some RCL control lights on that track, plug in your mediator box to the network, and suddenly you're going. You don't have to run tons of DMX cabling, which someone might not even install correctly in the first place. It really has been designed with that interface in mind. But it's all very well and good. You watching me control it, who's been controlling it for over a year now, wouldn't it be nice if you could control it? So our engineering team have dedicated an entire space so that you can have a play with it virtually as well. In one of our meeting rooms, we've set up 2 LensVector lights on the ceiling and a virtual version of the RCL Control app running on a Mac. So if you're interested in playing with it yourself, seeing how awesome it really is, drop us an email at sales@rclighting.com or give us a call and we'll book you in, get you a time slot, and you can have a play.